Now let's see how to create our own MCP server for Philips Hue integration and connect it with Claude Desktop. This is the code to build the Philips Hue MCP server, and I'll explain what each block of code does. This code first sets up the required libraries and prepares for asynchronous execution and multi-threading. It then loads environment variables and initializes a fast MCP server named Philips Hue to control Philips Hue smart lights. The getBridge function establishes and returns a connection to the Philips Hue Bridge using the IP address and username from environment variables. It stores the connection in a global variable and creates a new bridge object if one doesn't exist. If required information is missing or the connection fails, it raises an exception. Once connected, it returns the bridge object for controlling Hue devices. The turn on lights is decorated with MCP tool, making it available as an MCP API endpoint. The turn on light async function is used to turn on Philips Hue lights, either all or specific ones, based on the light ID parameters. It first calls getBridge to establish a connection to the Philips Hue bridge. If light ID is all, it uses getLight to fetch all lights and setLight to turn each on. Otherwise, it passes specific IDs and uses setLight for each. It returns a message indicating which lights were turned on. The listScene is also decorated with MCP tool, making it available as an MCP API endpoint. The listScene function retrieves and lists all the scenes stored on the Philips Hue bridge. It first calls getBridge to establish a connection, then uses getScene via run async for async support to fetch scene data. It processes the result by extracting scene names and IDs, formatting them into a readable list. If no scenes are found or an error occurs, it returns an appropriate message. The listScenes function is used by Claude or a custom AI agent to list all available scenes, allowing it to activate one based on the user's intent. Activate scene is also decorated with MCP tool, making it available as an MCP API endpoint. This function calls getBridge to connect to the Philips Hue bridge and retrieves all scenes using listScene. It loops through the scene to find one that matches the provided scene name based on user intent. If found, it activates the scene using runScene with a given group ID and scene name. It returns a confirmation message indicating which scene was activated and for which group. Now we need to register our MCP server with Claude Desktop by adding it to the Claude Desktop JSON configuration file, which can be found at Claude directory in the library on Mac. In this configuration, I am registering an MCP server named Philips Hue. It tells Claude how to launch the server using a command line tool called UE, pointing to the directory where my MCP server code lives. The config also includes environment variable like Philips Hue Bridge IP and username, which Claude will use to securely connect and control the smart lights. Now you can start the Claude Desktop, go to Search and Tools, and you will see the Philips Hue MCP added along with the list of all the tools.